When it comes to an experiment, everything revolves around scale. Something on a small scale does not necessarily work on a larger scale. Check out this line. But wait, it's not actually a line, it's a triangle. Let's say we are standing at the bottom vertex of the triangle and we want to get to the top left corner of the triangle. But we made a small mistake and walked along the hypotenuse by accident. If we walk 15 feet, that's not too big of an issue, and we end up 0.2 feet away from where we actually wanted to go. If we walk a mile, that will put us 70.4 feet away from our intended destination. That's a lot further away. Sending someone into space or launching a long-distance probe can have much larger consequences with even smaller mistakes. Keeping things accurate becomes especially difficult with functions like sine or e to the x. Most people go straight to the back of a textbook or grab a calculator when it comes to trigonometric functions. But those values have to come from somewhere. We can use sine values that we already know to figure out a possible substitute graph. For example, sine of 0 is 0, sine of pi over 2 is 1, and sine of negative pi over 2 is negative 1. We also know that sine of pi is 0 again, so we get this oscillating pattern. A function that's very similar to this form is the function negative x cubed plus x. It's not perfect, but after a little bit of fiddling around, we can make it possess similar values to sine. By adding even more elements to our function, we can get closer to sine. This series of elements is called a Taylor series. As a series, they all have a certain pattern that allows us to identify them and create as many terms as we like, using a so-called general term. In this perspective, you could think of the general term as a cookie cutter, the only limit being how much cookie dough you have. Though we know our values are close to the actual values of sine, we also need to know how close. Using a Lagrange error bound, we can calculate how far off we might be by looking for the largest possible error. This doesn't mean that our error is actually that big. It just can't be any bigger. Using this margin of error, mathematicians and engineers can be more certain of the effectiveness of their calculations without needing more time. After all, sometimes you just have to be close enough.